7.6, we're solving trig equations, and there are a lot of different things to think about before we start. We kind of want to plan ahead. You want to notice if it's linear or quadratic. Quadratic means you're going to see an x squared, or like a sine squared theta or something like that. Because you're going to have to proceed in different ways depending on what the problem looks like. If only one trig function is present, that's the easiest thing. We're going to be able to isolate the variable. That's what we want to happen anyway. But that won't happen all the time. And a lot of the times there's going to be more than one trig function. And so like if you see a sine squared theta and a sine theta, or if you see a sine theta and a cosine theta, or something like that. If there's more than one trig function, or there's more than one variable function, you're going to try to factor, okay? So set one side equal to 0 and try to factor and solve. Sometimes you won't be able to solve, but you can use quadratic formula. Otherwise, you've got some other tricks you can do. Maybe you can square both sides, or maybe you can use the identities to do a substitution or something. But you've got all these different things that you could try. I tried to set it up as this flow chart. I think that makes your decision process a little bit easier. Try and follow through this flow chart. It says the same thing as this chart, pretty much. Okay, so we look at example 1. We're solving 2 sine theta plus 1 equals 0 over the interval from 0 to 360. So look at the flow chart and ask yourself the question, how many variable terms are there? How many variable terms are there? There's only one. It's that sine theta, okay? It's not as simple as saying how many variables there are, but how many variable terms there are. I see one variable term, and so that makes this kind of easy because we're just going to go straight down here and isolate the variable. If there's only one variable term, we should be able to isolate the variable. And, think about if that said 2x plus 1 equals 0. I don't want to write that down, but you would subtract 1 and divide by 2. Hopefully you can see that. And it's no different. We're going to subtract 1 and divide by 2. Sine theta equals negative 1/2. We're not finished because we don't have the variable isolated. We don't have the variable by itself. And so if you remember back a couple of chapters or whatever, we're going to have to do an inverse sine. If you were using a calculator, you could think about this as, let's take the inverse sine of both sides. I don't know that we need to write that down. I don't want to write this down. But if I was using a calculator, I'm doing the inverse sine of negative 1/2. I think it's a lot better just to look at the chart. Okay? We know this, we recognize this 1/2 from the chart. And so if you use the chart, you're going to find your sine theta, and you're going to find your 1/2, and you're going to go backwards and find the angle that produces that 1/2. Okay? Now notice we're in degrees. That's something you're going to have to pay attention to because sometimes we'll be in degrees and sometimes we'll be in radians. Here we're in degree mode. So what angle would produce that 1/2 from the chart? 30. You should see that 30-degree angle. Okay? This answer is not negative 30. Don't say the answer is negative 30. That's not right. Okay? And it can't be right because you can't give me an answer that's not between 0 and 360. It can't be negative 30. That negative sign, remember, we've done this before. We're talking about what and where. The what comes from the chart. We got that 30 degrees straight from the chart. But the where, we have to think about where a sine function would be negative. Or where a y value would be negative. And I've done this a lot of times. We know the sine values or the y values are going to be negative downstairs in the 3rd and the 4th quadrant. And so what we have to think about is a 30-degree reference angle where sine would be negative. And so there's one in the 3rd quadrant. That's 30 degrees past 180. That's 210. And then there's one in the 4th quadrant. That's 30 degrees before we get all the way around to 360. That's 330. So when we look at this, when we try to solve this equation, the variable is theta, and that's what we've just found. We've just found 2 different answers. Theta equals 210 degrees and 330 degrees. Example 2, I'm solving a new equation. First thing you'd want to do is look at how many variable terms you see. When there's more than one, you're not going to be able to isolate. Go back and look at your flow chart. When there's more than one, you're going to have to do something else. And so what you want to try to do, you want to try and factor. So, go back and look at your flow chart. How many variable terms? Well, more than one. So we're going to go over here. Can you factor? Okay? Can you factor? And so that's what we're going to try to do. If we can factor, then that's going to be what we want. And that's going to be what we need. So you might notice that sine theta is going to be a common factor. Okay? There's going to be a common factor. And what we do when we try to factor, we always want to try and produce a zero. So I'm going to subtract sine theta over. I would have sine theta tangent theta minus sine theta equals 0. In order to solve by factoring, we need that equals 0. And that's what I've got. But what you would have to recognize is you'd have to recognize this common factor. Okay? Common factor. Think about if I had 4x squared minus 12x equals 0. You'd see a common factor of 4x, and you'd take that out, and that'd be x minus 3. And we could solve by factoring. It's the same concept. You just have that extra layer of trig on top of it. I'm going to write that down. We've got sine theta in common. And so if I knock out that sine theta, if I divide out that sine theta, I would have tangent theta minus 1. 1. Here equals 0. That's what makes this go. There's something called the zero product property that says that if you've got two things that multiply together to make 0, that one or the other is going to have to be 0. And so that's what we use here. We split this up and either sine theta equals 0 or tangent theta minus 1 equals 0. At this point, you might notice that what we've done is we've transformed an equation with more than one variable part down into a couple of equations with just one variable term. And we should be able to isolate either one of those two pieces. Let's do tangent theta minus 1 first. I think it's a little bit easier. I would try to isolate the variable, so I'm going to add 1. I've got tangent theta equals 1. If you're going to use a calculator, you're doing an inverse tangent. Okay, inverse tangent of both sides, inverse tangent of 1. That's going to give you the reference angle. But I'd rather you use the chart on this. We should recognize that that 1 is going to come from a chart. Tangent is sine over cosine. So we look at where we're going to get 1 there. So square root of 2 over 2 divided by itself is 1. And we can see that we're looking at a 45-degree reference angle. Okay, that has something to do with 45 degrees, but you would notice that it's 45 degrees where tangent is positive. Because that 1 is a positive number, we're looking at 45 degrees where tangent is positive. So think about that. And all students take calculus. Tangent is positive in the first and the third. You need to know that. So we're looking at a 45-degree reference in the first and the third. Well, first quadrant, it just is what it is. You've got 45 degrees. That third quadrant is 45 degrees past 180. Add them together, that's 225. So we've got two answers there. We have two answers there, 45 degrees and 225. Now let's go back and do sine theta equals 0. You look at your chart, and you can tell pretty quickly that it's going to be a 0-degree reference angle. But I think that's hard for students because they don't know about being positive or negative. There is no positive 0 or negative 0. A lot of the times they'll miss the second answer on this one. Okay. Whenever I get a 0 or a 1, I think it's probably most useful to look at the circle. That's what we're doing on all of these problems. It's just most obvious when I've got my quadrantal angles where I'm looking at 1s and 0s. We know those 4 points on the unit circle. And so if you think about what sine theta equals 0 means, sine theta is talking about the y-coordinate. And so I'm talking about where is the y-coordinate equal 0. And so we see that obviously it's at 0 degrees, but the y-coordinate is 0 at 180 as well. And so we have two answers here for a 0-degree reference angle. A 0-degree reference angle would give me 0 and 180. So we actually have 4 answers here. 0, 180, 45, and 225. You can put them in numerical order if you want to, increasing order if you want to, or you can just list them all out. That would be your 4 angles. And so think about what a solution is. A solution is a number that results in a true statement if you plug it in. That's what we've got. You plug any one of these numbers in to this equation, you're going to get a true statement. Down at the bottom, it gives you this caution, and I've seen this a lot of times. Students will try to look at this equation, and they'll say, well, sine theta on both sides, I can just cancel that out. And if they cancel that out, it's kind of tricky, but it would end up giving them tangent theta equals 1, and they solve that, and they end up getting their 45 and their 225. They end up getting those two answers, and those two answers are right, but this caution is telling you don't do that. If you try to cancel out, one of the variables, the problem is you're going to cancel out some of your answers. Okay? So we don't want to do that. We don't want to cancel out variables because we don't want to cancel out answers. Okay? You guys understand that? Good. Example 3, we're solving tangent squared x plus tangent x minus 2. And when I look at this problem, I can see there's more than one variable term. And so I immediately know I'm not going to be able to isolate. I want to isolate because that's easy, but I know I can't. And so when I look at this one, tangent squared x plus tangent x minus 2, I guess you need to train your eye, but it kind of looks to me like this. I don't know that you want to write that down, waste space, but that's what this looks like. It looks like one of those trinomials that we've factored 1,000 times from Algebra 1 class. Remember where you have to find two numbers that multiply to -2 and add up to this positive 1 right here? And so you'd say, well, that's x plus 2 and x minus 1. That's how that would factor. And so then we would solve this and say there's going to be a -2 and a positive 1 would be our solution. Now that's not exactly how this works because it's not a variable of x. We're really solving for that tangent x, and then we're going to do an inverse tangent at the end to isolate x. Okay? So, but keep in mind, that's exactly how this is going to work. The tangent x function acts as the variable. And so, once you recognize that this will factor, instead of saying x and x, you would say there's a tangent x and a tangent x. We need two numbers to multiply to -2 and add up to this 1, and that's gonna happen the exact same as what it did in Algebra 1 class. You're going to need a +2 and a -1 in order to get there. And so what we've just done is we've factored a trig function. We want to try and factor that so we can solve that. And what happens here, zero product property says that you'd either have tangent x plus 2 equals 0, or you'd have tangent x minus 1 equals 0. So what we have now are equations with only one variable term in them. Each of those two equations can be isolated. Now, if I looked at the one on the left, I'm going to subtract 2. I'd have tangent x equals -2. If I looked at the one on the right, I'm going to add 1. I've got tangent x equals 1. The one on the right is going to be easier to do because that's a chart question. That comes straight from the chart. You should recognize that 1 from the chart is going to come from the middle here. Tangent is sine over cosine, so we're taking square root of 2 over 2 divided by itself. And so you might say that's a 45-degree reference angle, right? Be careful though, because this problem isn't in degrees. So you wouldn't want to say 45 degrees. You'd want to say pi over 4 there for your reference angle. But we'll do what and where, and so that's pi over 4 where tangent is positive, because that's a positive 1. The tangent ratio is going to be a positive, okay, is positive 1. And so we're looking at a pi over 4 where tangent is positive in the first and third quadrant. All students take calculus, right? All students take calculus. We know tangent is positive in the first and third quadrant. So there's a pi over 4 in the first and a pi over 4 in the third. So the first quadrant just is what it is, pi over 4. The third quadrant, remember how this works, halfway around is pi. To get a common denominator, we'll call that 4 pi over 4. And so that third quadrant angle is pi over 4 past 4 pi over 4. That'd be 5 pi over 4. So there's half the value, 2 of your answers. Now the other equation is a little bit harder because it's not from the chart. So maybe you want to use a calculator. And with our calculator, we're just going to do inverse tangent of -2. If I want to solve this, I know I can do an inverse tangent of both sides. So x is going to equal inverse tangent of -2. So let's make sure we're in radian mode. We're going to do an inverse tangent of -2. You have to be smarter than your calculator here because that answer it spits out is not the answer. It looks like we have a negative 1.107, but you have to remember the what and the where. Really, that's talking about a 1.107 reference, and that is an angle. That's a reference angle where tangent is negative. Is that right? Because we see the tangent ratio is talking about a -2. We're talking about a 1.107 where tangent is negative. You're not allowed to have a negative answer anyway, right? This interval says that our answer has to be in between 0 and 6.28. So if you gave me negative 1.1, that's definitely not going to be right. So you have to look at that 1.107 where tangent is negative, meaning quadrants 2 and 4. And so we've got a 1.107. I rounded off in the second and a 1.107 in the fourth. So think about what that means. Okay? A little bit difficult, I think, with the decimals there. But halfway around, we know halfway around is pi. And so if I'm looking at that angle in the second quadrant, it's going to be pi minus that 1.107. So we can do that in pi minus 1.107. It's about 2.035. So we've got 2.035. That's your second quadrant angle. And then you've got the other one, the one in the fourth quadrant. Remember, all the way around is 2 pi. So it's 1.107 before you get all the way to 2 pi. 6.28 if you're estimating there. So let's do 2 pi minus 1.107. 5.176. 5.176. So we have 4 answers here in that interval from 0 to 2 pi. We have 4 answers. And I don't know about you, but I'd much rather deal with the ones that have that pi over 4 in them than the ones with the decimals. The decimals kind of play with our brains and make it look kind of difficult. But you could have decimals, you could have pi over 4 stuff. As long as you're in radians, that's it. Example 6, we're trying to solve this equation right here. First thing you should notice is there's only one variable term. Okay? And so that's good. When there's only one variable term, we can isolate. That's what we want to do. That's going to be the easier one. Okay? But what you also should notice is that there's a half of an angle. Okay? X over 2, there's a half angle. And so what we're going to have to do is take this interval and take half of the interval. We're only really going to look from 0 to pi for the half angle. Okay? X goes from 0 to 2 pi, but x over 2, my half angle, is going from 0 to pi. Okay? So when we solve this, we're going to isolate just like always. And so the first step, I'm going to divide by this 2. I would have sine of the half angle equals 1/2. Okay? Now, I'm going to have people try to do something about that 2, and I'm going to have people try to multiply by 2 or something and cancel that out. You can't do that. Okay? You're not allowed to do that, so please don't try to do that. Solving the equation is like peeling an onion, and you have to get rid of the outside layers first. Okay? The next layer we're going to have to peel off is this sine. You can't touch this 2 until after you've gotten rid of this sine. Okay? So make sure the next step you're going to do is an inverse sine to get rid of that sine function. We're going to have x over 2 equal inverse sine of 1/2. I know I'm writing probably more than what I would normally write, but that's what we're going to have. We have to do the inverse sine of 1/2. And so, I wouldn't use a calculator here. I'd use the chart, but whatever, either way. Use the chart, inverse sine 1/2. And you're looking at that 30-degree angle, I know, but notice we're in radians, so you can't say 30. You say pi over 6. Okay, does everybody say pi over 6? reference. It's a pi over 6 reference angle where sine numbers are positive. Okay, so pi over 6 where sine is positive. And so take a look at where sine is positive. You have pi over 6 where sine is positive. We know that's upstairs. And so we call this pi, no, wait a minute, with a common denominator, that's 6 pi over 6. Okay? And so the angle, pi over 6, before you get to 6 pi over 6, would be 5 pi over 6. And then this other one, you call this 2 pi, no, with a common denominator, that's 12 pi over 6. Oh, wait, no, I don't have to do that. What am I talking about? It's the first quadrant. So first quadrant just is what it is. So we have pi over 6 and 5 pi over 6. Okay? But if you think about it, okay, and this doesn't really come into play here, but you have to think about the interval. Usually when there's like a doubled interval or a tripled interval or something like that, it's going to come into play more. But what this says is for the half angle, which is the level I'm still at, I've got x over 2, I've got my half angle, it says I'm only allowed to go from 0 to pi. In this case, and this doesn't happen very often, but in this case, that's exactly what I have. I've got angles going from 0 to pi right now. And so I don't really have to do anything more. Okay? I don't have to do anything more with that interval. I'm already all set up with my interval from 0 to pi. But what I have to do now, the last step is to isolate x. And so, just think about if you had x over 2 equals 10, or anything, you multiply by 2 in order to isolate x. And that's exactly what we're going to do here. Okay? In order to isolate x, I'm going to multiply by 2. And so that cancels out the 2, and I get x equals 2 pi over 6 is going to be pi over 3. And this would be 10 pi over 6, or you can think about canceling this and 3. It's going to be 5 pi over 3. And so that's it. That's my answer. I just isolated x, and that was the original goal. Solving an equation, isolate x, you get pi over 3 and 5 pi. Part B says, then give all solutions. We're going to skip that for now. Maybe we'll come back to that later, but we're going to skip that. I want to go back into part A and just imagine what it would look like with a cosine. Okay, if that had been cosine instead of sine, if you had at the point where we were inverse sine equals 1/2, if we had done inverse cosine of 1/2, okay, inverse cosine of 1/2 would have been a pi over 3 reference where it's positive, but where cosine is positive is over here. And so I don't really care about the numbers all that much, but remember our interval was from 0 to pi. And from 0 to pi is going to exclude this angle right here. This one wouldn't count, and so we wouldn't count it. You'd only have one answer in that case. So you'd really only count this one. That would be a pi over 3, and that would be your x over 2 equals pi over 3. And so you multiply by 2, and x would equal 2 pi over 3. You'd only have one answer in that case, because the interval excludes that second angle. You really want to pay attention to that. Okay, you really want to pay attention to that, because it's going to be important. Really look at the interval. Don't ignore it. I know it's tempting to, but don't. When I see example 7, first thing that you should notice, I hope, is that there are two different variable types, okay? You can't put cosine 2x together with cosine x. They're not like terms. You have two different angles. One of them could be 50 and the other one would be 100 or whatever, okay? You've got two different angles. One's a double angle. And so I know I can't isolate, and I won't be able to factor either because they're different. So I'm going to have to try and use an identity, but luckily we have an identity. And hopefully you recognize and remember a double angle cosine angle. Cosine 2x has several different options. Cosine 2x, don't write this down, is cosine squared x minus sine squared x, or cosine 2x is equal to 1 minus 2 sine squared x, or cosine 2x is equal to 2 cosine squared x minus 1. We've got three different identities, or three different options, and we want to do a substitution. Okay. Now, if you compare the left side to the right side, what I'm going to want to do is use the one with cosine in it. I don't want to introduce an extra sine sine function. I don't want two different functions. I want the same function, and then hopefully I can combine the terms, or maybe I can isolate, or maybe I can factor, or something like that. And so, to me, there's only one option. We know that cosine 2x equals 2 cosine squared x minus 1. And we're going to do a substitution there. So take that, let's take this, and let's plug it in place of cosine 2x there. So, just doing that substitution and bringing this part down, I'd have 2 cosine squared x minus 1 equals cosine x. Which is good for us, I suppose. I've got two different cosine functions. I've got a cosine x and I've got a cosine squared x. And so that tells me I won't be able to isolate, but I think I'm going to be able to factor. And so that's what I want to do. Let's subtract this cosine x over so that everything can be on one side. I'd have 2 cosine squared x minus cosine x minus 1 equals 0. This is something that I can factor. Okay. To me, it kind of looks like this problem: 2x squared minus x minus 1 equals 0. Maybe that looks better to you or easier to handle. You don't necessarily need to write that down, but that's what it looks like to me. And when I factor this, I know there's a 2x and an x, and I need two numbers that multiply to -1, and then they're going to produce that -1. I can factor this. Remember, to do that, you think about FOIL. Whatever goes over here needs to be multiplied by the 2, and whatever goes here isn't multiplied by the 2. But you factor that, and then you can see that x is going to equal -1/2 or +1. If you don't know how to factor that, you can always use quadratic formula. Okay? So I'm going to factor. Maybe you want to use quadratic formula. It doesn't really matter. But we're shooting for that -1/2 and that 1. That's what's going to happen. When I factor this trig function, I'm going to have 2 cosine x plus 1, and then cosine x minus 1. The cosine x in this problem kind of acts like the variable did of my other one over there in green. So, splitting it up, 2 cosine x plus 1 equals 0, or cosine x minus 1 equals 0. I'm subtracting 1 and dividing by 2. There's my -1/2. I'm adding 1, and there's my 1. I still have that -1/2 and that 1, but those are equal to cosine x, and I'm still going to have to do that inverse cosine in order to isolate. So, do your inverse cosine, and notice we are in radians here, okay? And use a chart backwards. Inverse cosine of 1/2 is going to give me a pi/3 reference where cosine is negative. And so if you think about that, pi/3 where we're negative is on that left side. We get a common denominator here. We call this pi, but we call it 3 pi/3. And so I can see this one will be right before that. It's 2 pi/3. And then this one is right after 3 pi/3. So 4 pi/3. We've got a couple of my answers. Okay. Now, I don't know if you noticed, but as soon as we got to this step here, we no longer had a double angle, so we're not going to have to worry about doubling that interval. Okay. As long as we're just solving for x and don't have any 2x anymore, we got rid of that double angle. So when we got rid of that double angle, we didn't have to do a double interval. So my 2 pi/3 and my 4 pi/3, they're good. So then we look at the other one, look at cosine x equals 1. Sometimes students have a hard time with the 1s and the 0s. I would encourage you to look at the unit circle. We know the ordered pairs of certain points without having to think too hard. But the cosine x equals 1 means where is the x coordinate equal 1, and it's only right there. And so cosine x equals 1 is going to give away an angle of just 0. And so I can see that x equals 0 again. And so I have three answers. I've got three answers. They are 0, 2 pi over 3, and 4 pi over 3. Example 8, we're solving 4 sine theta cosine theta equals square root of 3. And the first thing I notice is there's two different trig functions I'm not going to be able to isolate. Okay? There's two different variable parts I'm not going to be able to isolate. So, I want to be able to factor. I don't know how to factor this, and so I'm probably going to have to use an identity. And so, hopefully, you can compare what you see on this screen here to something on the board or something on your formula sheet, something that you've maybe seen before. All right, so look over at the formulas and see if one kind of compares with this one. I don't see one that matches up perfectly, but there's one that's pretty close. If you notice, there's one that says sine 2 theta equals 2 sine theta cosine theta. And that's very close to what I have. Not quite exactly. And so I have to do kind of a little math trick to make this work. But if you notice, I know that 4 is equal to 2 times 2. So if I just change 4 into 2 times 2 and bring everything else down, then I see it. Okay? I can see the right side of that identity, that double angle sine identity is right there. 2 sine theta cosine theta is equal to sine 2 theta. Let's bring down this 2, and let's bring down this equals square root of 3. I've just done something really important because what I've done is I've taken an equation with more than one variable part, and I've changed it into an equation with only one variable part, which means that I can isolate this. Okay, I can isolate the variable in this equation. The only thing I'd have to notice is there's a double angle. I've got a double angle, and so I'm going to end up having to double the interval. And so, instead of 0 to 360, we're going to double that and go from 0 to 720. Okay, fine, whatever. We'll go around twice. That's what that means. So we isolate this variable. We've got sine 2 theta equals square root of 3 over 2. And be careful. Be careful. I know people are going to try to jump the gun and get rid of this 2. It's solving an equation like peeling an onion. You can't peel off an inside layer yet. We have to peel off the sine function before we can get rid of that 2. And so if I want to isolate the variable, my next step is going to be to get rid of that sine. I've got to do an inverse sine. And that's going to give me 2 theta equals. And so we look at our inverse sine of square root of 3 over 2, and that's where the chart comes in again. Inverse sine square root of 3 over 2. We are in degrees, so we can actually say that's 60 degrees, right? Well, a 60-degree reference where sine is positive. Okay, we have a 60-degree reference where sine is positive. So let's look at a 60-degree reference where sine is positive. So here and here. Feels like we're doing the same thing over and over again. That's because we are. We do the same kind of deal over and over again. If you look at these angles, I see 60 degrees here in the first quadrant. And then the other one in the second quadrant is 60 before 180. That's 120. So 60 and 120. That would be if I was only going around one time. But since we have a doubled angle, we're going to double the interval, meaning we go around twice. And so this 60-degree angle right here, if you add 360, we're allowed to add 360. We're going around twice. So let's add 360. 60 plus 360 is 420. Do the same thing for this one. This was 120. And if I go around again, I'm adding 360. That's 480. So here I'm going around twice. That's all I can do. Double angle, double interval, you're going around twice. You should be able to tell that you can't go around again, because if you added another 360, you'd be bigger than 720, and that's your boundary. Okay, you'd be out of bounds. So you have to be in between 0 and 720. The double angle does anyway. The regular angle, theta, has to be in between 0 and 360. And that's what we're trying to get. we're trying to isolate the variable. So the very last step that we're going to do, the very last thing we'll do is divide by 2. Let's divide by 2 and find theta. It's 30 degrees, 60 degrees. 420 divided by 2 is 210. 480 divided by 2 is 240. And what you would notice is that those four answers, those four angles, are in between 0 and 360. And that's what theta is supposed to be. That's the boundary of the theta.